All right, section 2.6, and I'm going to take basically all week to do this. We have 3 sections. I got A, B, and C for you to do. All right, so today we're just doing A, and let me make sure I do the right ones. You know how I've been harping about not using your calculator when you do fractions? Yeah. Well, and I see it in your eyes sometimes. You're like, yeah, whatever, Mr. Hamrick, I'm using it anyway, right? I know how to use my calculator to do fractions, right, Judah? And and you know, you think, I'm going to use it anyway. I don't care what you say, because you won't know the difference on a test or a homework or anything. I'm just going to use my calculator. I'm telling you what, you're going to wish you would have learned how to do your fractions because of what we're going to do today. So let's do a quick review. Let's turn back time a little bit and go back to 4th grade, 5th grade, I don't know, whenever you learn how to do fractions, okay? So this is going to look ridiculously easy at first. But what if you had something like this? All right? Don't you wish you were doing that again? I don't know, maybe. But I tell you what, I've had some kids this year just completely mess this all the way up. So what's the deal? I'm adding fractions, right? So you have to find a what? With 2 words. A common denominator. Now on this one, guess what? It already has a common denominator. No, I'm starting off real basic because we're going to do some things with variables and it's going to be a little more complicated, okay? But I want you to get the basic rules down. We're going to make it a little more complicated as we go on. So you got a common denominator, and so it's already the same, isn't it? So what's my common denominator? It's 3, right? So did you have to do anything to the 2? No. Did you have to do anything to the 5? No. So you just add those up, don't you? So you keep the denominator the same, and you just add them up 7/3. Just keep it 7/3. I'm fine with that. You don't have to change it to a mixed number. We good with that? Let's do another one. Let's go 5/7 plus, I don't know, 3/5. All right? What if you had something like that? Not much more difficult, but it is a little bit. You got to think of the common denominator. Is it 7 or is it 5? Or is it something else? It's something else. It's 35. Okay, it's called least common multiple. It's the smallest number that 7 and 5 both divide into evenly, right? And so it's just 7 and 5, right, which is 35. And then now, what do you do with this? 7 times. Now, I like to just do this in my head. When you're a little kid, you did this. Do you remember this? Times 5, and then you put times 5. Remember that stuff? All right. I don't think you necessarily have to do all that stuff at this point, do you? You can just think in your head. 7 times what? 5. So 5 times 5 is 25. All right. 5 times what? 7. So 3 times 7, 21. You get the idea? And so that's what? 46 over 35. Make sense? All right. What if we had something like this? I'm just making these up. 5 over x plus 2 over 3x squared. Okay, got to find a common denominator, don't we? So let's take a look. We've talked about least common multiples with things like this. So I've got it. Well, first of all, I got a 1 out in front, don't I? So what would the common denominator be with a 1 and a 3? It'd just be 3. Okay. What about an x and an x squared? It'd be x squared, because remember, all these numbers have to divide into the common denominator, right? Excuse me. So x squared. Remember the little, well, forget that. So it would be x squared. You remember that, right? We've talked about that in here, haven't we? And you should have done that in Algebra 1 and Algebra 2 and that kind of thing. So that's your common denominator. So what did you do here? You said, what did you do to 7 to get to 35, right? Or not just do to it, what did you multiply it by? What did you multiply 5 by in order to get to 35? You do the same thing here. What did you multiply x by to get 3x squared? 3x. Now in this situation, I may go ahead and write this up here because it gets a little more complicated this time. So I had to multiply it by a 3 and by an x. Do you agree? Okay. So what did you multiply? What did you have to multiply 3x squared by to get 3x squared? Technically 1, yeah. Okay. You can say nothing, that's fine. But yeah, technically a 1, so you multiply that by 1. You really didn't change it, did you? So what are we going to have now? Yeah, so you multiply that together, so you get 15x plus what? Just 2, right? That's it. Can you really simplify that? No, not really. You just keep it like that, and then you're done. You get the idea? Now look, could you have done that? Could you plug that stuff into a calculator? No, you couldn't. All right, so it's important that you know how to add and subtract fractions. without always using a calculator all the time. Now that's fairly simple stuff right there. We're going to get a little more complicated. All right? Some of our denominators are going to have a sum, which means it's going to be a plus or a minus. All right? Even when I say minus, what's another word for subtracting things? The answer to a subtraction problem. You always learn what? The answer to a subtraction problem. What word do we use for an answer to a subtraction problem? What is it? It's the difference. Remember that? No? Yes? Okay, good. So it's the difference between two numbers. But when I say a sum, watch this. 3 minus 2, somebody would say, oh, that's a difference. But technically, that is a sum. And you're like, that's not a sum. I thought sum was plus. Well, it is a plus. It's plus what? Negative 2, isn't it? So when I say a sum, I could be talking about a subtraction or an addition. Make sense? All right. I just wanted you to understand. So when I say sum and then I put a minus here, you're like, oh, Mr. Hamrick, that's not a sum. That's a difference. It really is a sum, okay, if you think about it. Just plus the negative. All right, let's do example. You ready to do example? Good. So am I. All right, let's do it. 3p minus 1 over 3 minus 2p over p minus 1. Oh, you know what? Wow. I think I might have been leading you a little bit down the wrong path. Not exactly, but I kind of was a little bit. As far as adding fractions together, I just kind of glanced at this and thought we were just adding stuff together, but we're really not. We're actually solving. We're solving for p. So it's a little bit different. To tell you the truth, I think it's a little bit easier what we're going to do compared to adding the fractions together. So let's just, oops, I just want to move this a little bit away from that word solve because I need a little bit of room here. Let's see, before I do the example, let's let me see if I can make something up off the top of my head. I wonder if they have a, they probably don't now. They start right off with the example. Let me think here. What if I did this? What if I said x over 3 plus 2x over 5 equals 7/3. I don't know. I'm just making this stuff off the top of my head. I don't know. We could solve for x this way. You could find a common denominator and all this kind of stuff. But if I wanted to solve for x, let me say this. Initially, what do you not like about this problem right here? What's the main thing about this that you don't like? And don't say, well, it's because it's a math problem. Don't say that. But because the fractions, exactly right. Okay, I look at this, I'm like, ugh, fractions. Don't you? Don't you have that sinking feeling in your heart when you see fractions? Yeah, I think we all do. But we got to get over that a little bit. Because what I'm going to do is I'm actually going to do a little trick. It's not really a trick, it's just a method, okay? It's a way to get rid of the denominators. And one way to get rid of the denominators, and we're going to apply that to this thing up here, all right? I just tried to make this one a little bit easier. So I want to apply something. I want to do something. I want to get rid of those denominators. Now remember in Algebra 1, what was the main rule that you learned in Algebra 1? Whatever you do to one side, you what? You have to do to the other side, okay? So that rule still applies right here. So I want to get rid of the 3, the 5, and this 3 right here. So I would like to cancel it out. I would like that to cancel out with something up here. And then it would go away, wouldn't it? All right, well, what do I want up here so that that will cancel out with it? Well, I could have a 3, but then do I just put a 3? If I stick a 3 here, does the 5 cancel out with a 3? No, so I want something up here that all the denominators will cancel out with. So a 15 would be that, wouldn't it? It's the same thing as finding a common denominator, isn't it? All right. So 3 and 5 and 3, what would my common denominator be? It would be 15. Because 15 is the smallest number that 3 divides into evenly and that 5 divides into evenly. Does that make sense? It's basically a common denominator. It's a least common multiple is what we call it. Remember that, LCM and all that? Okay. So what we're going to do is we're going to multiply that by 15. Now look, will the 3 cancel out? Yeah, it will. But so will the what? So will the 5. You see that? That's why I didn't just multiply everything by 3. Okay? And then I got to, whatever I do to this side, look, I multiplied everything on the left side by 15. That means I have to do what to the right side? Multiply that side by 15 as well. You get it? So let's see what happens. 3 goes into 15 how many times? 5 times. Let's do this one. 5 goes into 15 3 times. This 3 goes into this 15 5 times. We good so far? Looks like a jumbled mess, but let's clean it up. All right. The whole reason we did this is to get rid of the denominators. So let's see what we get now. We get what? 5x plus what? 6x equals what? That's a 5 right there. That's a 5 times 7. Okay, it's multiplication. It's not addition. Multiplication, right? So it's 35. We good with that? And now, look at that. Now that looks way better than what we started with. Wouldn't you agree? You don't get a sinking feeling in your heart when you see that, do you? You're like, you look at this, you're like, oh, that's easy. It's no big deal. So let's do it. It's 11x equals 35. Divide by 11. And then basically, you can just leave it like that. I'm fine with that. 35 over 11. That doesn't simplify, does it? So you just leave it like that. Again, I just made that up off the top of my head. It worked out okay. Make sense? All right. If this was a high school math book, then they probably would have started off with an example similar to this. But it's a college book, and they go right to this one. But I think it's a good idea to see a simple version of that. Everybody got that down? All right. So you can always go back and look at it. So now let's go back to this. So what am I going to do here? Actually, let's change colors. What do I want to get rid of? What don't I like about this? I don't like the fact that I got fractions here. And what makes it a fraction? Basically, the denominator makes it a fraction, doesn't it? If I didn't have a denominator, I wouldn't have a fraction, would I? Okay? Technically, you always have a denominator because it could be 1, right? But you know what I mean. Other than 1, it's going to be a fraction. So what am I going to have to do? I got to find a common denominator. Well, look at my denominators. I got a 3, and I got p minus 1. So how do I find a common denominator with something like that? That's right, just 3 times p minus 1. Exactly right. Does that make sense? Because remember, it was a 3 and a 5. How did I get the denominator? 3 times 5. You get it? So, but this one's a little more complicated. I got to go 3 times what? P minus 1. And then I have to do that to everything. Okay, I can't just do this to the one thing. I got to do it to everything. So 3 times p minus 1. Same thing over here. 3 times p minus 1. Good? So far? All right, what did we do in that last problem? The whole reason I did that is so I could do what? Cancel out the denominator, right. So watch what happens here. See this 3? Cancels out with that 3 right there. Everybody see that? Look at this. What cancels here? P minus 1. That's right, because it's being multiplied, right? So now the 3 still stays there, doesn't it? All right, but the p minus 1 goes. Does anything cancel here? No, because I didn't have a denominator here. All right, well, technically it's 1, but you get the idea. So what do we got here? I've got p minus 1 times 3p minus 1. Well, let's write it like that. Let's not try to do that too quick. Are you thinking ahead? As soon as I wrote that down, what are you thinking? Give me one word. Foil. Okay? Do you see it? All right. Put a minus. Minus what? Got to multiply. What do I got here? I got a 3 and I got a 2p, so really it's just a 6p. I could multiply that, right? Equals. What do we got here? P3. Do I want to write it P3? Now let's write it what? 3p. And we'll do the distributing in the next step. Just trying to write stuff down right now. Now that looks a little bit better, doesn't it? All right. In fact, I think it looks a lot better than what it did to begin with, because I didn't like those denominators in there, did you? Now we don't have any denominators. Now I can work this like a basic, regular, algebra problem. First of all, what am I going to have to do, though? I'm going to have to multiply some stuff together, aren't I? So this multiplication right here, what do I want to do to that? I want to distribute, right? Or FOIL, whatever you want to call it. So let's do that. So p times 3p is 3p squared. Then the outside is minus p. The inside is minus 3p. And then the last is plus 1. And then you still have that minus 6p on that left side, don't you? So I just drop that down. Equals, let's go ahead and distribute this. So that's going to be 3p squared minus 3p. Good so far? right. We got to solve for p, right? Yeah, I got like terms. I do. Yeah, let's go ahead and just do that. I see something else that I was going to do, but we can add like terms and then we can worry about moving stuff over. Yeah, that's what I was going to do right away. You could do that now or you could do it later. It doesn't really make any difference. Yeah. Yep. So you want to just do that now? Let's just do that now. Watch. Subtract 3p squared from both sides, and that goes away. That worked out nice, wasn't it? Okay. Now let's go ahead and I tell you what. You know what else we could do? You could add like terms, but look at this. I got a minus 3p and a minus 3p here. So look. So they're going to, yeah, add them to both sides. They're going to go away, right? So if I have something on one side and exactly the same thing on the other side, they're going to cancel out. Get it? Now we can add like terms. So what do I got? Negative p minus 6p is negative 7p, right? And then a plus 1. I could put plus 1. I'm just going to put the 1 right there. You okay with that? What about the other side? Cancel everything out. What's up with that? What's that going to be then? It's going to be a 0. Exactly right. It's going to be a 0. We good? So you can do this a couple ways. I like to do it like this. I like to add the 7p over here. I don't know why. I just like the variable to be positive. 1 equals 7p. Does that make any sense? All right. A lot of people always like the variable being on the left-hand side. I don't really care. I'm kind of more concerned. I would rather have the variable being a positive, okay, with the coefficient being a positive. So anyway, what do we do now? Divide by 7, and there's my answer. P equals what? 1/7. And that's it right there. The hardest part was this part right here. Okay, it was getting rid of the denominators. Once we got the denominators and we got this stuff, it was just clear sailing, wasn't it? All the way down. Then we were good after that. That didn't look so bad, right, when I'm sitting there explaining it. But you know how it goes. You can sit there and watch me and you think, oh yeah, piece of cake, got it. But then you see a problem and then you get stuck. So you got to practice them, okay? You have to practice. Now, I know we don't do things out of the book and I just give you worksheets all the time. But you know what you could do if you needed the extra practice? You could look in the book, all right? You still know where your book is? Okay. You go to your book, okay, find the odd problems because they do have the odd problems in the back, all right? Find a problem that looks like the stuff that you're doing, all right? Find an odd one so you know what the answer is going to be. You work it out, see if you get it right. Now, you don't get any extra credit for it. I'm not, giving you 5 points for that or anything, but it's not all about the points, though, is it? It's about learning the material. So sometimes you may want to do that on your own. Ready for another one? Rousing answer there. Appreciate your enthusiasm. All right. So, yes, Mr. Hammock, I'm ready. Bring it on. That's what you should be saying. I want to hear it. Say it. Daggone, you guys are weak. It's no enthusiasm. No enthusiasm for math. Can't believe it. It's hard to understand.
You got the block right before lunch.
What's that mean? People after lunch complain because it's after lunch. So, is that an equals or... Oh, that is equals. I can't see. +2. All right, here we go. Well, let's see. We're trying to solve for x, right? It says to solve. What don't you like about this? The fractions, correct? Now, does everything have a common denominator here? Not really, because that's a 2 over 1, isn't it? All right. So how do we get rid of that x minus 2? That color's too close. Let's go green. How do we get rid of this x minus 2? I don't like that. I don't like that in the denominator. So we just spent 2 problems talking about that. So please answer me. Don't make me feel bad. That's right. Multiply everything by x minus 2. You got it. Multiply this by x minus 2. Multiply that by x minus 2. And multiply this by x minus 2. Multiply everything. Not just one of them. Multiply everything by x minus 2. Now, why did that help us? Well, it helped us a lot. Because look, bang, bang. That cancels. Right? And they cancel because it's being multiplied by x. This is being multiplied by 2, so they cancel as well. Bang, bang, they go. We good? What do we have left? We just have x right here. Then equals. What do we have here? Just a 2. Oh my goodness. This is easier than the other one, isn't it? What about the other one? Yeah, you can distribute it right now, couldn't you? 2x minus 4? Sure. I like the x's to be positive, so I subtract an x from both sides. That'll give me an x here. What's that going to be? A minus 2, right? So what do I do there? Add a 2, so x is equal to 2. If you need to do the steps, do them, but you should be able to look at that. So that should be your answer, right? Yeah, we did all the math, right? But I see something here. Remember, when we solve for x, we should be able to plug it back in, right? And then the left side will equal the right side. What about this makes it a problem? That's right, because look, if x is equal to 2, that means if I put a 2 in for this, this is 2 minus 2, which is what? 0. So I'm going to have a 2 over 0. Can I have a 2 over 0? No, because you can't divide by 0. Okay, so what do you think?
You wouldn't make the answer negative, would you?
Nope, you can't just do that. Is there always an answer for every single math problem you ever did? Like in Algebra 1 there probably was. Probably every problem they gave you in Algebra 1 came out to some answer, right? But when you got to Algebra 2, something weird started happening. You started working stuff out, right? And you're like, wait a minute, that doesn't work. Okay, I can't put it back in and it works, can I? So that's the situation right here. So what do we say? There's no solution. Okay, so we say there's no solution. Or some people say the null set. I don't know. Depends on what you want to say. I like saying no solution. That seems better to me. Okay, so you got to make sure that when you put it back in, then it works out. That's what's important about a denominator, okay? Especially if you see a minus right there. So if I see x is equal to 2, in fact, even before I even started this problem and looking at this, I'm like, you know what? X could probably be a lot of different numbers, but there's one number that it can't be. And what would it be? It would be 2, right? And guess what? Lo and behold, guess what we got? We got x is 2. So that means there is no possible solution. There is no number that exists in this world, if I put it in for x, that this left side will equal the right side. There's no such number. Okay? So that's why it's no solution. Does that make sense? Okay. Alright. Let's do another one. Yeah, I think after we do this one, I think that should cover everything for the worksheet. So let's give it a shot. What color haven't we used? I like this purple right here. Let's try this one. Can you read that all right? On the screen it looks good. On this screen. So m over 2 minus 1 over m equals 4m plus 5 over 12. Alrighty. Let me see what happens here. Okay, let's do this. What's the first step? Get rid of the denominators, right? Because it's an equal, right? We're not just adding fractions here, are we? We're trying to solve for something, okay? You've got an equal sign. It's an equation. So I want to get rid of the denominators. So what's that? 12m, good. Find a common denominator, right? I got 2 and 12. What number does 2 and 12 divide into evenly? What's the smallest number that 2 and 12 divide into evenly? That would be 12, wouldn't it? Some people might say 24. Would 24 be wrong? No, it wouldn't. Okay, but we want the smallest. It's a lot easier if you find the smallest one. Okay, you could still work with 24. You're just going to have to reduce at the end, and it might be more complicated. All right, so I like to use the smallest number possible, and that would be 12. And it's a 12m. So what do? We multiply everything by 12m. Now look, I'm multiplying this sum by a 12m. So look what I do. It's very important that you do this, that you put that in parentheses. Okay? I could put the 12m right here. It doesn't matter. You with me on that? All right, let's see what happens here. The whole reason we multiplied everything by 12m so that the 2 would cancel, the m would cancel, and the 12 would cancel. That was the whole point of doing this. Does that make sense? Okay, so watch. The 2 will go into this 12 how many times? 6. This m cancels out with this m. This 12 cancels out with this 12. Everybody see that? Now, it looks like a big old mess right now, doesn't it? Let's clean it up a little bit and see what we got. Now, we're not going to have any denominators, are we? So let's see what we have here. Don't forget anything. I got a 6, I got an m, and I got another m. What's that going to give us? That's going to be 6m squared. Good. Okay, minus. And then, yep, I just have a 12 right there. Equals, what do we have here? Remember, this canceled out, right? So it's 4m squared plus 5m. Good. Everybody see that? That looks a lot more pleasant, doesn't it, than what we started with? What do you think? Looks like a what? Give me a good fancy math word. I got a m squared, I got an m, I got a constant. Give me a nice, good math word. It's a weird math word. Starts with a letter we don't use too often. Starts with a Q. Quadratic. Thank you very much. Okay, this is a quadratic equation. All right, because when you have, remember the quadratic equation is? It's ax squared plus bx plus c equals 0. All right? Yeah, I guess they call it standard form of a quadratic equation. All right. So what are we going to do? We're going to get the x squared, the x, and the constant all on the left-hand side. We're going to set it equal to 0. So we're going to take both of these things, chuck it to the left, set it equal to 0. You good with that? We can do this in our head. What are you going to get now? You're going to get 2m squared, and then what? Minus 5m, and then minus 12, and that equals what? 0. Okay. Now look what you have. You got a quadratic equation. You got several different ways to do this. You could see if it factors. You could complete the square. Or you could use what? Quadratic formula. All right. It's up to you on how you want to do this. Now they actually factor it. Do you want to factor it? Just so we remember. You guys are okay with the quadratic formula, so I don't think we really have to go over that again. Let's go over factoring just to kind of put it back in your head a little bit. All right. So what do we have here? 2m here. We got m here. Now watch. You got to multiply. These have to multiply to be negative 12, and then the outside and inside have to add up to be negative 5. Okay. So one's going to be negative, one's going to be positive, right? Because when I multiply together, I get a negative. I have to have two different signs. And then I've got a couple choices, don't I? Well, I have several choices actually for 12. I got 1 times 12. I got 2 times 6. I have 3 times 4. And then I got the reverse of those, don't I? All right, so I've got like, what, 6 different options that I could pick right here. So what do you want to try? 1 and 6? 1 and 6 is 6, not 12. It's either 2 and 6 or 1 and 12. Which one? Which one do you want to use? Or you could use 3 and 4. I don't know.
Wait, what's the middle one there? Oh, it's a
Well,
is it even gonna work?
well, watch. Remember, the outside and the inside have to add up to negative 5, not just the 3 and 4, 2 and 6, 1 and 12. Remember? Because you got a coefficient out in front of this. So let's try 3 and 4. Okay. Where do you want the 3? First or second? First. Okay. So 3 and 4. So let's see if it works. Remember what we do to check to see if it's negative 5? The outside and inside. So the outside is what? Negative 8. The inside is plus 3. Negative 8 plus 3 is negative 5. Check that out. That works perfect. Remember what we said about the factoring? Sometimes you guess and you get it just right, and sometimes you got to move on. Yes. All right, let's get back to this. What do we do here? I've got these things equal to 0, so what do we do? Remember this? 2m plus 3 equals 0. M minus 4 equals 0. So it's coming back to you. Seems like it was just last week we did this, right? I don't know. Maybe it wasn't last week, but it wasn't too long ago. And then you just solve for m. Subtract 3, divide by 2. So that would be negative 3 over 2. Add a 4, m would be 4. Okay. Let's just check the bottom to see if we're okay with that. Now look, I'm not putting anything in the 2 and the 12, so really it's the m. So can I put a negative 3 halves in for that? Yeah, sure. Can I put a 4 in for that? Yeah. It's not going to go to 0, is it? The one answer I could not have would be what? 2? Why 2? That was the other problem. Come on, this is a different problem. I could have a 2 here. Come on, think about what you're saying. I could put a 2 right here, because 1 over 2, that's a number, isn't it? All right. Could I put a 12 here? Yeah, 1 over 12. I could put a 12 here. What could m not be? Come on. 0, right? The denominator can't be 0. You only have a variable here, right? Okay, so the denominator cannot be equal to 0. On the other one, look, we didn't say 0 because the denominator wasn't just x, was it? It was x minus 2. So I said x couldn't be a 2 because if it was a 2, then the denominator would be what? 0. But if the denominator is just a variable, that means the denominator cannot equal 0. And actually, you'll see that sometimes. You'll see them write an equation or maybe even a formula. Sometimes you'll have a formula. And in fact, like the quadratic formula, x equals negative b plus or minus square root b squared minus 4ac over 2a. Usually we just write it like this. But if you look in a math book, my guess is that they're probably going to tell you something. They're going to say that a cannot equal 0. You see that? Because think about it. If a was equal to 0, it wouldn't be a quadratic formula anyway, would it? It would just be a straight linear equation. So you wouldn't be able to throw it in here. You wouldn't get two answers anyway. All right, anyway, I'm going too far on this. But do you get the idea? A could not equal 0 because 2 times 0 is 0. You can't divide by 0. All right, enough of that. We good with that? All right. I think I've covered everything that you should be able to do on this worksheet. Let me just double check. That looks fine. Yup. All right, so you should be able to do everything on this worksheet. It's section 2.6, and we'll call this one A. All right, so that's what we're doing today. All right, that's it.